All right, today we're going to simplify some trigonomic expressions, and we're going to use these three sets of identities to do that. So basically, we're going to substitute in something from here into our problem. So we got the quotient, two quotient identities, six reciprocals, and three, basically, they're called Pythagorean identities. All right, so the first one, sine and secant. Well, sine, we've got sine equals 1 over cosecant, so we could use that. And secant is 1 over cosine, so we could use one of those two. Let's just start with substituting out the sine, see if that works. So sine is 1 over cosecant. 1 over cosecant times secant would give us secant over cosecant. Is that anything we have on here? That's cosine over sine, sine over cosine. No, I don't see that, so that doesn't really help. So let's not sub out the sine, let's try and sub out the secant. And secant is 1 over cosine, so we keep the sine, we sub out the secant for 1 over cosine, multiply those together, and you get sine over cosine. And that is something. That's right here. Sine over cosine is the same thing as tangent. So therefore, this whole thing is equal to tangent theta. That's how this simplifies, tangent theta. So that's the strategy here. You just look at what you're given, and you sub one of them out and see if it simplifies into something else on here. If it doesn't, you start over and you sub the other one out and see what you get. So let's try another one. How about tangent cosine? Tangent theta times cosine theta. All right, we got a couple choices with tangent. Tangent, we could use 1 over cotangent. The cosine over cotangent's not on here, so that's probably not going to help. We could also use sine over cosine. That looks like a winner. I'm going to probably try that. Or we could sub out the cosine. The only thing I see for cosine is 1 over secant. So if we did that, we'd have tangent over secant, which I don't see that on here, so that's probably not going to help. So let's use the tangent is equal to sine over cosine. So we got sine over cosine times cosine over 1, basically. Anything is a fraction over 1. So when you multiply two fractions together, you can cross cancel. You remember this? Like if you had 3 over 4 times 4 over 2, that would give you 12 over 8, which reduces to 3 halves. So you could just cancel the 4's and get straight to 3 halves. All right, so that's what we're going to do here. We're going to cross cancel, and our cosines are going to cancel out, and we're just left with simply sine theta. So that just becomes sine theta. So both of these two problems have reduced down to just one trigonomic function so far. So that's been some pretty good reduction. Let's see about this next one. Now it's starting to get a little crazy here. 2 times secant squared theta plus minus tangent squared theta. All right. When we start getting into the squareds, now we're talking our Pythagorean down here. So do we see a secant and a tangent? Yeah, the second one here has got a tangent and a secant in it. It's just in a little bit of a different form. It's solved for secant. Secant squared is equal to tangent plus 1. So let's try that. We'll substitute out the secant for tangent squared theta plus 1. And then we still have this minus tangent squared theta. So inside our parentheses now we've got a tangent theta minus a tangent theta, so that's going to cancel out, and we're just going to be left with the 1, and 2 times 1 is 2. So essentially secant squared theta minus tangent theta is equal to 1. And that would make sense if you took this identity right here, which I'll write it a little bigger so you can see it, but it's tangent squared theta plus 1 is equal to secant squared theta. If you just subtract the tangent to the other side, you end up with secant squared theta minus tangent squared theta, and that's what we started with, and that is equal to 1. So this was just 2 times 1, which was 2, in case you forgot what 2 times 1 was. All right, so that looks scary, but that wasn't so bad. Another squared one here. Cosine squared theta minus sine squared theta. All right, and we almost have that. We have cosine plus sine is equal to 1. This is cosine minus sine. It's not equal to negative 1. It doesn't work that way. Basically, we got to solve for either cosine or sine here and substitute it into this problem. So since cosine is positive, let's solve for cosine. So to solve for cosine in this trig identity, you would subtract the sine to the other side. And then cosine, when you subtract sine to the other side, would equal 1 minus cosine or sine squared. So we subtracted the sine to the other side. So that's what we're going to put in for our cosine. So we'll end up with 1 minus sine squared theta minus another sine squared theta. So we've got 2 negative sine squared thetas. So we've got 2 of them. So instead of writing it down twice, we could just say 1 minus 2 sine squared theta. Is that getting us anywhere? Doesn't appear to be getting us anywhere less complicated than what we started with. So I'm not so sure if we were barking up the right tree there. So maybe we can try substituting out the sine, or solve for negative sine squared. So we'll start with our identity here. That's the identity. We could subtract sine to the other side. And do I like that? Might have to say I'm going to have to come back to this one. Why can't I figure this one out? Let's try it. Let's subtract the sine to the other side. And we could subtract the 1 to the other side. Oops, minus 1 is equal to negative sine squared theta. So now we've figured out what negative sine squared theta is. So we could substitute that in. Cosine squared minus 1. So instead of negative sine squared theta, we could have a positive cosine squared theta minus 1. So let's try that. So that would become a positive cosine squared theta minus 1. And then this would be 2 cosine squared theta minus 1. So it's kind of the same place we were when we substituted out the other one. We end up with 2 cosines minus 1. The other time we ended up with 2 sine squareds. And I just don't see how that is very helpful. So I don't know. Maybe that is considered simplified and that's it. Doesn't seem much simpler than what we started with. It's the best I'll have to think about that one some more. Let's move on to another one here. Sine theta times cosine theta all over tangent theta. All right. This is back to that other one where it was pretty helpful to use sine over cosine. We already have a sine and a cosine, so if we can get rid of that tangent and get some more sines and cosines in there, it's probably going to reduce. So let's try that. So we'll get rid of this tangent theta in the denominator and make it sine over cosine. So basically, I'm going to rewrite this as a long division problem instead of fractions. So I'm going to say this is sine theta times cosine theta is our numerator, and we're dividing it by the denominator, which is sine theta cosine theta. And when you divide a fraction, you flip it and multiply. So this is actually sine theta cosine theta times cosine over sine. So now we can cancel out our sines, because remember this is like over 1. It's the cross canceling again. So we're just left with 2 cosines being multiplied together in the numerator. So that's cosine squared theta. And that may be probably all you need. I mean, if you use this one here, you could say that cosine squared theta is equal to 1 minus sine squared theta. So I don't know which one's considered more simplified, but those mean the same thing. And that's what this boils down to, is one of those two. Next, 2 minus 2 sine squared theta in the numerator, cosine theta in the denominator. Where are we at on time here? We're already at 11 minutes, so this is probably going to be the last one here. All right, in the numerator, you can factor out a 2. There's a 2 in both terms here. You got one term minus another term, and they both have a 2 in it. So you can pull out that 2, and then you have 1 minus sine squared theta, and that is this one right here if you just subtract sine to the other side. So 1 minus sine squared theta is equal to cosine squared theta, because this is your Pythagorean identity. So if you subtract the sine to the other side, you get 1 minus sine squared theta, and that's what we have here. So we're just going to turn that into a cosine squared theta. So you end up with 2 times the cosine squared theta, which is, you don't really need the parentheses, it's just 2 cosine squared theta. So that whole thing right there is just equal to 2 cosine squared theta. I guess there's only 2 problems left. It just has to be a long, boring video. You guys are older, you can have a little bit of a better attention span. I try and keep my junior high videos a little shorter, because I know they aren't paying attention after like 30 seconds, but maybe you guys will pay attention a little better. All right, secant theta times sine squared theta. Oh, this one's getting crazy. 1 plus secant theta. All right, I can already tell I don't like this one. I should have stopped while I was ahead. All right, well, I don't even know where to start here. Let's say the sine squared theta. Is that going to help? I don't know about that. 1 plus secant theta. I mean, that would have to be squared. But even that was not quite right. Yeah, I'm not really sure on this one. I mean, we could try and substitute out the sine squared theta. Sine squared theta is equal to 1 minus cosine squared theta, which I don't really see how that's going to help, but let's just try that, I guess. So our numerator would be secant theta times 1 minus cosine squared theta all over 1 plus secant theta. Secant is equal to 1 over cosine. So, I mean, technically you can move the secant into the denominator and make it a cosine, because that's what secant is equal to, is 1 over cosine, but I don't see how that really helps anything. You've got cosine times the 1 plus secant theta now, which doesn't seem to be getting us anywhere closer to simplification. Seems more like it's more complification, if that's a word. If not, it should be. So I don't know. I'm going to have to think about that one. Not really sure on that one. I almost feel like that denominator should have been squared. I'm going to say that was a typo. If it was 1 plus secant squared theta in the denominator, then we could probably do something with that. So, let's see how that one plays out. All right, one more. Sine squared theta minus cosine squared theta times sine squared theta. When is enough, people? All right, sine squared theta minus cosine squared theta times sine squared theta. Well, I'm going to guess that we got to get rid of this sine squared theta. Sine squared theta is equal to 1 minus cosine squared theta by this right here, subtracting cosine to the other side. So you could say that's probably not going to be helpful. Now you're going to be multiplying two things together that both have a minus sign in it. I don't see how that is very helpful. Maybe you want to substitute this into that sine squared theta. So you'd have 1 minus cosine squared theta minus another cosine squared theta times sine squared theta. So that would be 1 minus 2 cosine squared thetas times the sine squared theta. And I mean, you could distribute this through, say this is sine squared theta times 2 cosine squared theta sine squared theta. And that just seems to be getting us nowhere fast. So again, I think I've failed miserably on simplifying this problem. So what was that? 3 of them that I'm not sure on? Definitely the last two just doesn't seem to be much more simple. I don't see how this is any more simple than that. It actually looks more complicated. We went from just one sine, 2 sines and a cosine to, we still have 2 sines and a cosine, now we threw a number 2 in there. That would actually be a minus sign, sorry about that. Yeah. So there really is no tried and true, like, hey, do this every time and it's going to work. It's more like you got these things here that you can substitute with. You can replace, sine theta with 1 over cosecant. You can replace a lot of things with this here, and you just got to kind of guess and check and see which one helps cross cancel, simplify things. And if you can't figure it out, then you'll just have to get that one wrong. I don't know. There's got to be a way. So maybe that was enough to get you started on the right track. Maybe you can figure out the riddle from here.